All right, so good evening, everyone. This is the first of the DevOps class. My name is Obuso Ezekiel, and I'll be taking you on today's class. It's going to be a very, very interactive session. And yeah, so DevOps. I'm sure a lot of people have heard what DevOps is, what is DevOps, how DevOps works, and everything. Yeah, this is going to be a very interactive class, like I said. And one thing you need to note while on this class is that we are dwelling on the beginners. So I'm sure most of you are bosses on your own with your own various experiences. But for this class, it's a complete beginners class. So we are starting from the very bottom. So I urge you to pay attention, watch the videos when you watch you know take in the class when you can, and yeah, so that's just it. So before I start, let's quickly run through what we are going to learn during this whole session. We'll start what we are going to do today with understanding DevOps and DevOps life cycles and principles. Yes, that's what we're going to do today. Then there is the benefits and use cases of DevOps with overview of popular DevOps tools. That's what we're going to do in the next class. That's for week one. So the week one basically is going to talk on um week one is basically going to talk on just a lot of talk, the introductory sections, what DevOps is about. For those that have no idea about DevOps, it's going to introduce you to everything you need to know about DevOps ecosystem, the DevOps, yeah, just DevOps engineering in general. So from week two, we're going to talk about source code collaboration because that is like the most important part of the training. Source code and collaboration with Git. There's no way you can be a DevOps engineer successfully without properly understanding Git, and everything that comes with source code and collaboration. Then the second week, we're going to talk about branching strategies and collaborating on a project with Git. Yeah, so for week three, we're going to talk about Linux basics and networking fundamentals. Yeah, so like I said, being a DevOps engineer, we're starting from the basics. So Linux is one of the most important components of being a DevOps engineer, being anything that has to do with, development and operations, that what DevOps is. So we're going to talk about Linux basic and networking fundamentals, talk about the importance of learning Linux you know, for managing systems, especially in production environments. Next thing we're going to talk about is OSI models and system administration. That's for lesson two of the third week. Then for the other week, we'll go into scripting. So um scripting is a very important component to automating certain processes in DevOps. We'll talk about scripting in with tools like talk about scripting with tools like Bash and Python. So Bash and Python, they are scripting languages. I'm sure most of you have heard of Python in terms of programming, but Python is also used to script. So scripting means, writing a sequence of code to be able to execute a sequence of functions instead of, executing the functions one by one by one. In a DevOps environment, you won't want to execute multiple functions one by one by one. You want to write scripts that automate everything and run at once to save you time and to save your business time as well. So we'll learn about that one. Then we'll learn about configuration management. Configuration management is using tools like Ansible. So on a high scale, Ansible is, like I said, the configuration management tools that manages the installation of packages and just management of servers at the same time. So you use tools like Ansible to install and manage components on multiple systems. It can be either a server, it can be multiple containers and the rest. So sorry that I'm be saying things that are abstract. When we go into the class, we'll understand everything better. Then we'll go into Ansible configuration management using rules. Then we dive down to containerization with Docker. Docker is a containerization tool that help you package your application, your softwares, and enable these softwares to run on multiple environments. Then we'll go hands-on. This is where we'll really go hands-on. From Ansible, we'll start going full hands-on. Then we'll introduce CI/CD, and we'll go hands-on CI/CD pipeline with GitHub Actions. Then we'll go down to monitoring, where we'll talk about Prometheus, Loki, and Grafana. And we'll go hands-on as well. Then we introduce cloud computing. We're not really going to go deep into cloud. We'll just talk about the essential components, which are the EC2 instances and the S3 buckets and networking. Then we'll wrap it up by learning architectural design. So as a cloud DevOps engineer, you also learn how to design some architecture, because there are some certain deployments that you want to make. You will be the one to design the architecture that will accommodate these deployments. So yeah, you will learn about that. And then DevOps, putting together a well-structured DevOps portfolio and DevOps career growth strategies. So that's what we'll be covering for the next few weeks of the training. These are what we'll be covering for this time. So yeah, before we start, any question? Please, if you're raising up a hand, I can't see you. So just unmute your mic and ask your question.
Good evening, sir.
Good evening.
Okay, my name is Godwin Daniel.
All right, Godwin.
Okay,
welcome.
please, thank you, sir. I want to find out, is there a way we can get this course outline?
Yeah, it's on your LMS. It's on the LMS. Just go to curriculum on your LMS and you see everything I just listed out. It's on the LMS.
All right, thank you, sir. Appreciate it.
Yeah, no problem. So yeah, moving forward, let us now start the meet. Okay.
Yeah,
all right.
hello. Sorry. Yeah, good evening.
Yeah, good evening.
Yeah, on the elements, we cannot click on you cannot see it, the outline, the curriculum. When you click on them, they cannot collapse. They don't collapse to see what's actually, like, there's no note under them.
Oh, okay. That's actually from my end. I didn't add any notes. I just gave like but I'll sort that out after the class. I just gave like an outline, like what we are going to learn on top. Yeah. But I'll get to it after the class. Can you hear me?
Yeah, okay, thanks. Thank you.
Okay, no problem. So now let's do this. Now, introduction to DevOps. That's what we're going to do today. My name is Obuso Ezekiel Lumisi, and I'll be the facilitator for this training. So, yeah, so what is DevOps basically? DevOps is a culture, this is a definition. DevOps is a cultural and technical movement that aims to improve collaboration, note, between development and operations teams. The aim is to enhance software delivery speed, quality, and reliability. Now, I'm sure most of you have heard of, in tech, basically, most of you have heard of developers. Oh, I'm a developer. Oh, I am a software engineer. Oh, I write code, basically. Also you have heard of, oh, I am a system administrator, or I manage servers for my company. I'm the person that is in charge of networking for my company. Now, the main aim of DevOps is to fuse these fields together, because they realize that over time, if you notice, when people deal with legacy systems, now legacy systems are systems that run on old set of code. Most people don't like to update legacy systems because when it's running, why fix it? If you notice, when they want to make any change in the legacy code, they will have to probably make announcements, nationwide announcement or company-wide announcement before they can make a change in the code, which affects in the long run. You know, see situations where let me use what we are familiar with, our banks. You know, most banks, I'm not talking about banks don't practice DevOps, don't get me wrong, but there are some situations where they want to make an upgrade and you have to shut down for a while before fixing something. Now, that is the aim of DevOps. DevOps fuses together development and operations where deployment, where software movement is easier and automated. You get? So you don't have to do a lot of pick and drop. You don't have to do a lot of manual processes. For example, I don't have to carry my software, zip it, and go and dump on the server. You know that kind of thing that people do autonomously. That is what DevOps aims to cover. Now, the key aspect of DevOps is automation. That's the key. That's the number one thing that DevOps aims to solve: automation, by reducing manual intervention and human error. You know, it enables faster and more reliable software releases. That, like I said, situations where, oh, you want to deploy a change now, probably for a user that is currently waiting. You don't have to probably start making announcements or start, you know, thinking of how you make the change without the system going off. That's what the DevOps process is. You get? Now, DevOps as well also promotes collaboration. It encourages open source communication between development and operations teams. Like I said, just like what I said now, it enables that communication between development. So you as a DevOps engineer, you're basically working two roles. So most people may ask at this point, what do you really need to be a developer to be a DevOps engineer? My answer will be yes and no. Yes, because it helps. Because it helps. It's like an added advantage. But no, because if you have good technical background, if you have good like technical knowledge, you can still solve. Even if you don't have and you're willing to learn, because as far as you understand what the code is and the dependencies that come with the code, it's still part of the whole DevOps. You still have to learn like that's what makes the whole DevOps process. So you don't really need to be a core developer. You don't really need to be like a die-hard operations engineer, like a system admin. Oh, I run servers and networking. It's a fusion. So when you always begin in a field, you always be given like a code base. You always be given like, oh, this is a particular code we're trying to deploy. Your job, you may not necessarily be the one to develop the code, but your job, you have to understand the code to be able to deploy it. You get? So that's part of it. Fusion of development and operations teams. For the operations side, apart from the code, you have to understand networking, you have to understand the server configuration, because where you're deploying the code to is a server. And you have to understand how to configure that server. Sometimes you may be deploying codes in containerized environments using Docker. You have to understand how to work on the containerized environments. Sometimes you'll be deploying codes in serverless environments. You get to learn all those ones. You have to understand how to operate those environments. That's where the operations come in. So development and operations is infused to what we know as DevOps. And as you can see from the diagram, you will see DevOps. So dev is build, code, build, and test. Code, build, and test. Now, like I said, you read The code is written, the code is built, the code is tested. That's what they call the software development lifecycle. Then there's a release. This release now is the point where your code moves from your computer to the server, to the containerized environment, to whatever the environment you're sending it to. This is what they call the release. Then there's the deploy. When the code finally lands on the server, how stable it is. Is the server is the server responding well to the code? Are there some dependencies you need to fix? Are there some things? This is where the deploy and operate comes in. Are there some things that you need to add? Are there some configurations? Thank God you are seeing Ansible here. There are some configurations that you need to add to the deployment to make that software work. That is what operate. Now there's monitor. Monitor is like the apex. You get money. So when the software is stable, you have to monitor it. Is the traffic coming into the server so high? Is the traffic coming low? The situation, there are concepts of what we call auto scaling. Auto scaling means adding more volumes to your server or adding more group of servers. We'll discuss about that when we get to AWS. That's what you when you monitor, you ask yourself, should it scale? Do you need to add more servers to accommodate traffic? Do you need to reduce servers to improve the cost? Those are the decisions you need to make as a DevOps engineer. It's not going to be easy, you get, because sometimes you can be on call for hours because you need to make these decisions. You need to either release a particular software or you need to monitor the particular, especially for situations where you are just launching. You understand? I've not really had personally, but I've had a friend where they deployed an application and, with the whole social media vibe and everything, with the whole social media noise and everything, the traffic spiked so high that they could not manage it and the thing went off. The application was down. So these are the kind of things that you will be required to mitigate. You'll be required to make on-demand decisions. Situations where the traffic is going up, what can you do at that point? You get that kind of stuff. So that's what being a DevOps engineer is all about. In a nutshell, that's what being a DevOps engineer entails. So hold on. Okay, yeah, sorry about that. So yeah, how does DevOps differ from traditional IT? So the first one is approach. Traditional IT siloed teams. Now, what I mean by siloed teams is that developers, people that work in a particular software, environment, they tend to work alone. So you can be a developer, you will just work alone. Then when the software is ready, you go and look for who will deploy it, or you go and start working all the way to the operations team with probably flash drive, that kind of thing. That will now probably help you to deploy. And then the operations, when they get your software, they're on their own, they're doing their stuff by themselves. That whole process, the communication back and forth is, cut short because there is no flow, basically. But with DevOps, there's more collaboration. I can be a developer. Developer can meet you, deploy the code. Your own is just to push the code, set up the server, run the pipeline, and then push the code to the server. You monitor everything. If there's an issue with the code, you report back to the developer, or in situations where you are the developer. Sorry, please. After my session, I'll answer your question, Karen. In situation where you are the developer, you can easily, roll back, sort your issues, push again, and everything works. There's more collaboration. Now, deployment. Deployment, traditional IT is more manual, infrequent, but in the DevOps environment, it's more automated and frequent. So you can push changes. You don't have to overthink before pushing any change. You don't have to overthink. You don't have to think about your life, that kind of thing. You have to, you can easily make changes, and once they are approved, you can easily put them in the environment. Then there's a feedback loop. So feedback loop, like I said earlier, if a situation where the deployment fails probably because there's a bug in the software, you can easily just check. You can easily just, in the traditional IT period, you have to go back to developers and start asking questions and, start trying to debug and everything. But here, there are tools that you can use to fix your code. There are code scanning tools within that whole, deployment process that you can use, and you can easily point out where the code is having issues, and you can sort it out, and deployments goes further. Infrastructure. Infrastructure is manually managed. So, like I said, the operations, you get to manage your servers by yourself. You get to do all the operations, set up everything by yourself. But DevOps, there are tools there are infrastructure as code tools where you can easily write the code and it will build the infrastructure. And when you build the infrastructure, you can easily run the deployment to the infrastructure. Then there's risk management. Risk management is high in traditional IT due to manual changes and reduced due to automation and monitoring. In this case, since everything is automated, you know that, everything is going in at once. You can easily monitor everything. If there's any issue, you can easily roll back. This is what they call a rollback to the previous version, or report to the necessary team, and everything will be sorted out. So yes, so that just it. Now, DevOps as a cultural and technical movement. This is just basically what I said earlier. Cultural aspect encourages open source and shared responsibility. Developers and operations teams work together to improve efficiency, transparency in goals, workflow, and feedback loops, ensures smooth collaboration, breaks down silos between teams. So traditionally, development and operations teams work separately, leading to inefficiencies and miscommunication. DevOps fosters cross-functional teams where members collaborate on design, development, deployment, and monitoring. Technical aspects: use of automation for efficiency, automated testing, provisioning, and manual configuration. Configuration management reduces manual effort and errors. Implementation of CI/CD pipelines. CI/CD means continuous integration, delivery, and deployment. So continuous integration ensures frequent code integration and early detection of bugs. Continuous delivery ensures that code is always in a deployable state, and continuous deployment automates the release of software into production, reducing lead time for new features. Like I said, all these are the preliminaries, the preliminaries that we need to learn before we get into the meat of the matter. So, yeah. So there are key concepts in DevOps, which I've explained earlier. There is collaboration and communication, bridging the gap between dev and ops, which is, like I said, development and operations. Continuous integration, automating code integration and testing. Continuous delivery, ensuring code is always in a deployable state. Continuous deployment, automating the release of code into production. Automated testing. So all these things are part of the DevOps, the software development lifecycle that encompasses everything you do as a DevOps engineer. Automated testing, testing code functions, classes written by developers, testing code, functions and classes written by developers to verify their functionality. Then there's infrastructure as code, a practice that uses code and configuration files to manage infrastructure such as servers and networks. Monitoring ensures enterprise-grade reporting capabilities that help development teams understand the availability and performance of their applications. Yeah, so this is just it. These are all the key concepts. When you talk of DevOps, when you say, oh, I'm a DevOps engineer, this in a nutshell is your core responsibility. So when you tell you, oh, I'm a DevOps engineer, this, what you're seeing here is your core responsibility, your collaboration, implementing continuous integration, implementing continuous delivery, implementing continuous deployment, automated testing, infrastructure as code, ensuring that all infrastructure that is built is properly managed with infrastructure as code. You don't build in, yes, you know that people always say, oh, you can build with normal manual processes on AWS, but in a standard practice, you need to build with infrastructure as code tools. So when you're setting up those servers and all those networking, everything is aligned and deployed, seamlessly. The monitoring ensures enterprise-grade reporting capabilities that help development teams understand the availability and performance of applications. So that's just it. This class is not going to be a long one. It's going to be short. Like I said, it's an introductory class. So yeah, build like that. So this is what I explained. This is what I explained previously. The life cycle follows structured workflow plan. So, like I said, for every project you want to do, anywhere you want, whether you as within an outside tech, you need to plan. So when you're building a project, like I said, the development team, operations team, even if you're not the one writing the code, you also be part of the code that, making decisions concerning what the code will be. But ideally, I'm not saying that you cannot be a DevOps engineer if you don't know how to code, but ideally you should be able to interpret the code to a good extent. Yeah. So plan, you first of all plan, develop, you write code, version control, and peer review. Then build. Building means compiling code. So for those people that are developers, when you write the code, you build it into artifacts, you build it into, build files, then test. You run testing. Now, in DevOps environment, testing is not manual. That's why it's, in DevOps environment, automated testing. You run the automated test, you run security checks. Very important, because there are situations where there's some things that you may not find in your code, but you may find it because you may not find in your local environment, your laptop, but you may find it in your production environment. So you have to test that scenario to ensure that there are no bugs. There are situations where some people go and deploy like password. Some people go and deploy code that contains password, open passwords. Security checks like this will check those code to ensure that there are no security vulnerabilities within the code. There's performance validation as well. You have to do what they call browser tests for those that are deploying front-end code. You have to do end-to-end tests, unit tests, and all those kind of tests. Then there's the release. The release point is a very, very sensitive point in the DevOps lifecycle, because when everything is properly tested, you now want to. It's like performing a lift and shift. I don't know if we're ahead of that one. Lifting something from a particular environment to a new environment. Now, introducing it to that new environment can come with a lot of challenges, and it's very, 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 very technical. So it's the point, and it's a point where people need to be careful. Then you prepare the artifact, you do approval. So once all the tests are done and it passes, then you release. Then the release is now when it's now deploying to the staging or production environment. When it's deployed now, you now operate it. That's why you now ensure that, oh, okay, the environment where it's deployed in can properly handle the software. There are no issues in that environment, not just in your own. This one is not in your laptop or in your local environment anymore. In that particular environment, there are no issues, because that is the environment that the users, that as if you're deploying like a web application, that's the environment where the users themselves will communicate with. So you have to ensure that everything is good. Now, the last one is monitoring, collecting logs, So you have to collect logs. Logs are like, records of activities. We'll explain that one in the monitoring part. Tracking performance and gathering feedback. So when you gather feedback like, oh, XYZ set of people. For example, now feedback can be, oh, Android users are having issues with the app because 10 Android users have complained, or iPhone users are having issues with the software because 5 users have complained. So you now go back and then try to figure out what the issue is and either deploy it as an update or most times just deploy it as an update. It can be a major update, it can be a minor update. So yeah, that's just the whole English in general. So yeah, that's it. So it's a very, like I said, it's a very short class. This is like a very, 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 very short class. And we need to get prepared. We need to get prepared for everything that these 3 weeks will have for us. Everything I've mentioned here, including when you get to the curriculum, everything you see is everything we're going to learn. And yeah, you'll be given assignments, you'll be given tasks, you'll be given hands-on training. So this is an introductory class to introduce you. By Friday, our next class, we'll talk of the benefits and other introductory sessions. Then we will now move over to Git. I want us to understand Git properly. That's like the first step because, yeah, Karen, good day. Please, you can ask your question.
Hi, Ezekiel. Good evening. Thank you
Good evening.
for thank you for the lecture so far. So please, I have a question and it's from your first slide. I don't know if you could,
From my where?
your first slide,
Okay.
the first one. Yes, please.
First. Okay.
Just like someone said in the group, okay, I think the second is, yeah, thank you. Just like someone said in the group that is looking scary, right? So I wanted to come.
Okay.
The second one, sorry, not the second, the one that had all the tools.
All the two. Wait. This one,
No, yes, thank you.
this should be it now. Yeah. So
Yeah,
first things
yeah.
first. Okay, continue. Let me allow you to finish. Continue.
So my question is this, looking at everything you've explained there from the development side to the operation side, is it that all tools that, targeted to each of them, are we using everything or
No.
we
The thing.
just using?
Okay, let me explain. I know it may be scary, but these are tools that are relating to each point. Now, one thing about DevOps you need to understand is that DevOps is a profession of tools. You do more tools than actually even write code. Because most of the things that you want to do, like deployment, release, operations, monitoring, deployment, you work with tools. Now, yes, I won't lie, most of these tools are synced to each of the components that are outlined here. You get, but this is not what we are going to. Yes, we're going to learn in terms of GitLab. We are going to learn GitHub Action. Like that was what I plan to explain in the next class. We'll learn Git, we'll learn AWS, we'll learn Docker. Now, for this part, Chef, Ansible, and Kubernetes, we're only going to learn Ansible. Then for monitoring, we're only going to learn Grafana. Then this is Jenkins for CI/CD, but we're not going to learn Jenkins. We'll learn so yeah, we'll learn GitHub Action. So you get to learn a lot of tools. So that's why a lot of people are saying, oh, it's scary because you have to learn this tool, this tool, this tool, that tool, that tool, that tool. That's how it is. Let me not sugarcoat it. That's how it is. But everything all boils down to getting the job done. You don't really need to learn it deeply, but You just have to have a good knowledge of everyone, which is what we are going to introduce in this class. For every component that we go to, like I mentioned earlier in the curriculum, they have their own tool and we'll work on. It's not a tool that you have to install on your computer. It's a tool that you can easily just, do it hands-on and get it done. You can we'll do a hands-on and can just install it or something like that. It's not something that, I would say you must prepare or something. It's just as the class goes and everything, you just get it done. Or some of them are even web-based. You can easily just go to the URL, sign up, and work on them basically. So yeah, don't be
All
scared.
right.
Sorry.
Okay. And this leads to the second question under
All
the
right.
dev, right? You see the aspect of code. You said in that we are going to, is it write code or something? So for someone that does not have the knowledge of coding, like, and you don't have the knowledge at all. So is it that you need to go and learn how to code to be able to understand DevOps?
No. Yes and no. I answered this question in class. I said yes and no. It is beneficial, but it's not compulsory. You get
Okay.
it is beneficial that you know the code. But if you are, like I said, that's why I said the DevOps is a profession of collaboration. You will always collaborate. Even if you are not a developer, you will always work with a developer. And when you work with a developer, the developer can always point you out to things that you need in, because developers will do the work manually, like writing all the code, writing the test. You are just automating it and deploying. So the developer will always point you, or you can easily learn. You can go through the code, go through the video. For example, now you want to deploy a Node.js application. A Node.js application has a particular template or has a particular way to be deployed. You just based on now, you have to now consider the various different dependencies that are in that application. But it's like a template. So it is the same pattern you will use, the same set of steps you will use. So what you just need to do now, I'm working in an environment where I have to deploy a JavaScript application. You gotta learn how to deploy a JavaScript application. When you learn how to deploy a JavaScript application, you now come and relate it to the particular JavaScript. Okay, what is here now that I can change? From what I've learned how to deploy a JavaScript application, what is the difference? This my JavaScript has this component, has that component, let me add it. These kind of things are all learning. But like I said, it's not compulsory because you can easily learn it. You can be given a PHP application. Like I know someone that he was given a Ruby on Rails. I'm sure you must have heard of Ruby on Rails. Oga did not know Ruby on
Yeah.
Rails from Jack. But he deployed the application because he has to learn how to deploy a Ruby on Rails application to the Docker container. He learned it. You go through the application. Okay, when you're learning stuff, you will see how their own is when you're learning. You go to your own and see, okay, is it the same thing? Are there any other extra things that's in this my code that is not in the code that I'm watching or learning from? You add it. If the ones that are there are not, you want to remove it here, you remove it and then you deploy. Everything boils down to stability. Sometimes you can deploy it and it's not stable. You roll back, you remove what you need to remove. You can do it. Everything you can deploy again until it's stable. Everything boils down to the application being stable enough to operate and monitor, which is the last part. So that's just it,
Okay.
basically. So
All
like I
right,
said,
thank
it's
you so much.
beneficial. Like I said, it's beneficial, but it's not compulsory. But it is a good thing because if you know how to code, you can do two people's work. You can, just that they will pay you more, you get. But me, I won't lie, I won't deny the fact that I didn't really know how to code as much when I was learning DevOps. But I had the idea, like I had like a surface level knowledge of programming languages. So when I jumped into DevOps, when they say, deploy a PHP application, I knew what a PHP application, I knew the components of a PHP application, and I knew how to now transform it, move it to a deployment. You get? It's all those things you can easily
Yes,
learn them. But like I said, I will still say it again, it's not compulsory, but it's beneficial. Yeah, that's just it.
thank
All right. So, Victor Oyemachi, please, okay, go on to your question.
Good evening, sir.
Good evening.
She has asked the first question the question I wanted to ask. But I have
Okay,
this other question. I don't know. It's not about what we talked about today, Sha. But I just want to ask.
okay,
It's still about DevOps and cloud.
okay,
Okay. Um, I've been hearing that DevOps mostly runs on cloud, like you deploy applications and softwares on the cloud. That's why
okay.
it makes use of
AWS.
AWS,
Yeah, okay,
Azure, Google.
okay,
Okay, this one is about me. I'm currently taking the CCP exam,
okay.
and after this, I'm supposed to go to
SAA.
SA. Yeah, so
Uh-huh.
since DevOps is my niche, do I still
Okay.
need to do that SA?
Yes, you do. But one misconception people think, can you hear me?
Yes, I can hear you.
One misconception people think is that you are only deploying to cloud. You're not only deploying to cloud, bros. You can deploy to what they call on-prem environments. You can deploy
Okay.
to private cloud. So there are some situations like in financial institutions where their systems are embedded inside their environment. For example, a company can decide to buy their own server, their own network,
Yeah.
you get, and
Yeah.
configure it themselves. And you are the one that are deploying to those networks. So that's why I say you have to understand networking. You have to,
Yeah.
not necessarily cloud. Cloud is just like renting a house. Per se,
Correct.
when you rent a house, you don't really know the underlying work that the landlord did to build the house
True. True.
until you build the house, until you buy land and build the house. So most companies, what you just do in cloud is, okay, we need a server, we go and collect 2 gig of server from AWS. Oh, we need a database, we can collect 5 gig of database from AWS. There are some companies that build all those components themselves, and they expect you to manage it. So in
Yeah.
that situation, you must understand networking, you must understand networking, you must understand server configuration, which is Linux, because most of the servers, 90% of servers
They
are
run
Linux. That's
online.
why we are learning Linux. You
Yeah.
get. Then
Yeah.
you will now be expected to deploy. When you will deploy, most of those servers will come with IP addresses. That is what you now use to deploy applications to. So it must not necessarily be cloud. Cloud is just a situation where cloud is the reason why we learn cloud, because these are rented infrastructure, and most companies use cloud, but there are some companies too that don't deploy to cloud. All their
Yeah.
infrastructure are private, and so that is why we are learning the underlying. Most people will just, once you pay money to learn, they just take you straight to AWS and teach you AWS. But Linux, you don't know Linux, you don't know networking, you don't even know the what's that part of the curriculum I said? The model, the physical layer, all those model layers for networking. You don't know all those ones. That's why you just see, when you just get certification, you cannot do anything because you don't know the fundamentals. You'll give a Linux server to operate. There are even situations where you have to move from an on-prem server to the cloud. You have to migrate application migration. If you cannot operate the underlying system, you cannot operate. It will be difficult for you to operate the cloud. That's why we are learning this one. Then we'll now learn the cloud. You
Okay.
understand? So it's not necessary that people deploy to the cloud. No, cloud is just an extra, like, okay, let us just see how the environment looks like in a public space, public environment, like the cloud and everything. But the underlying ones are the ones that are the most important. That's just it.
Okay. Okay.
Mm.
Thank you, sir.
Did I answer your question?
Yes, sir.
Okay.
So, okay,
So
okay. So the SA is important, yeah?
yeah, essay is important. All those ones are important, but you need to this class gives you that fundamental that you need. All those
Yeah.
SAA are for the AWS environments. You
Yeah.
get, because SAA will not teach you Linux. SAA will not teach you Git. I've
That
studied
means,
SAA before, even if I've not written it. I studied for
okay.
it before. SAA will not give you Git. SAA will not teach you the networking layer. You
Yeah.
get. So
Yeah.
that one is just embedded in AWS environment, everything related to AWS. But these are fundamentals that you need. You get. That's
Yeah.
just it. So when you're deploying application, you don't necessarily deploy even Kubernetes that people talk about. AWS have their own Kubernetes, but there's some companies that
Don't use it.
there's some companies that build their Kubernetes from scratch privately. So when you're in that situation now, you don't know the underlining of Kubernetes. How will you now go and operate the managed one? That's how it is. So that's why we are teaching you the fundamentals.
Okay.
Yeah.
Yes, sir.
So yeah, any more question? Okay, let me go over to the message, to all the messages.
Hello, good evening, sir.
Yeah, good
Good
evening.
evening, everyone.
Good evening.
Sir, sorry, sir. Please, I actually have two questions, sir.
Okay.
Okay, so my first question is, please, I would like to know, is there like an interval we should be expecting that maybe after taking 2 classes, we should be expecting to have our tax, or
Every week, your tax will be dropped every week.
okay,
So
every
the
week?
ending.
All right, sir.
Yes.
Okay, sir. My
So
second
just
is, okay,
continue.
sorry, sir, you were saying. Okay,
No, continue, continue.
the second is, please, the material you are using, like your slide, they are very detailed and has a complete organogram of what we want to do. I don't know, will it be possible for you to, apart from the class recording, to share the material with us?
And now one, I'll have to go back to the management on that, but we'll get back to you if it's
Oh,
something that we also have like some resources that we can refer you to, but we'll get back
okay.
when we go back, because this is like an intellectual property, so we have to go back to get it.
Oh,
So
okay,
yeah, so
sir.
that's just it.
All right, thank you so much,
Let
sir.
me, all right. So any more question? A lot of people are so this particular question that is here, software testers. So yeah, software testers, they test code. So what, yeah, software testers will have to do theirs before the DevOps. Yes, so software testers will do theirs before the DevOps just, so the DevOps creates like the permission. So let me explain it to you in this way. Software testers to test the code will send it back to developers. Sources of test, they could send it back to developers. Then once it's approved, when you're creating tests, you're putting it in a pipeline. So once it goes through the pipeline, the pipeline scans it, all the security. So what the test that we normally do is mostly just security testing. What software testers do mostly is just like components, like testing if this particular thing is working or not. But what we do is we check if this particular dependency has bugs or has like I said, passwords and the rest. Software testers, they do more of checking if this particular button is working, or I don't know how to explain it in a nutshell, but that's just what it is. Because software testers sometimes they don't really know the coding. So they cannot really detect if, like, for example, you went to code a password inside your code. So it is the DevOps that actually does all those checks. The DevOps that does all those, does all those other checks. So I don't know if I answered your question. Yeah, so okay. All right. So difference between DevOps and cloud computing. Cloud computing is a generic term. DevOps is like when I say it's a sub-niche or like a niche, basically, of cloud computing. So cloud computing is the entire umbrella. DevOps, there's site reliability engineering, there's platform engineering, there's infrastructure engineering, all those umbrella under cloud computing. So you're a cloud computing engineer. Are you a DevOps engineer? Yes. Are you a cloud computing engineer? Yes. But can you be a cloud computing engineer? Yet you may not be a DevOps engineer. So being a cloud computing engineer, you can be a platform engineer, you can be a site reliability engineer. So there are different. So DevOps is like a sub-niche. Cloud computing is the entire umbrella. So I don't know if that answers your question. So yeah, basically. So I don't think there's any more question here. I hope if you know, site reliability engineer is not the same thing as DevOps. Now, you are making me talk more than I was supposed to talk in introductory class. Now, site reliability engineering, you know that part when we talk about monitoring in the DevOps lifecycle, there's what they call monitoring there. There are people that are paid to actually monitor, get logs, get reports, interpret reports. Those are what they call site reliability engineer. Ensure that the site is working, site is up. When it's down, they find out the reason why it's down. So DevOps, site reliability engineer is not the same as DevOps at all. You can be a DevOps engineer, but you don't know SRE. You can learn it, but SREs, they don't do deployment as much. That's not your job description, basically. But you can learn it if you want to add an extra skill. I don't know if I'm answering your question. Go that. Okay. So, what's the future of someone with just basic knowledge of? Oh. You cannot really say I won't say you don't have a future, but you need to learn. That's just it. DevOps involves deep learning. It's not really enough because it's not really enough to be a junior. You have to learn. You have to get yourself to a good extent. One thing about being a DevOps is if you know, you know. So if you know, you'll be very, very good and relevant. So you don't just really have to depend on junior developer. You have to keep on. So the future is bright if you're willing to learn, if you're willing to improve yourself, build projects, push yourself out there. So that's just what it is. All right. Okay. I hope you will be with me for the 3 weeks. So yeah, that being said, I think there's no more question.
Hi, sir.
Okay.
Sorry to cut you short. You said it's 3 weeks.
Did I just say 3 weeks? 3 months. Sorry.
Okay,
Sorry.
okay. Like you
I
said
made
it
a
like
mistake.
twice. That's why I'm asking.
Sorry. I apologize. It's 3
Okay, no
months. 3
problem.
months.
Thank you.
Sorry. It's just an error. Sorry, it's 3 months. So yeah. Sorry, I'm so sorry about that mishap. So yeah, that's 12 weeks. I was supposed to say 12 weeks, but yeah, that being said, thank you very much for today's session. You can always reach out to me on the Discord server. By next week, we'll start learning Git and we'll drop your next tasks for Git on the LMS, and just follow up. If you have any questions, reach out. Please don't reach out via DM. Most of you are reaching out via DM, which is not ideal. Just tag me on the group and I'll respond as much as I can. DMs are not really allowed. So yeah, basically. So thank you very much for this first class. I'm glad that people had questions and they were answered. See you all on Friday. Yeah, thank you.
This Friday, please, before you go, this Friday, right?
Yeah,
Okay.
yeah, definitely. Tuesday and Friday.
Okay, thank you.
Thank you. There's no WhatsApp group. Any WhatsApp groups are prohibited. Everything is on Discord. Thank you.
Thank you, sir. Appreciate it.